Hello team, today's challenge is captured chess pieces, where we are given an array of current pieces on the board and we need to figure out what our captured value is. So we need to do a little bit of a reverse on this, where the values of these, we can't just sum the values of these. We need to basically sum the values of these and subtract it from our total, which is kind of interesting, right? To get into this, I'm going to copy this object because I want to start here. I want to create this and do some stuff. In fact, I want a const. We're going to call this piece points, I guess, is a good name. Maybe you pick a different one. And that is going to be an object. Okay, we're going to paste that back in there and use some multiple cursors for the win. So right here. Excellent. I'm going to delete everything before that first quote. And then I'm going to jump to the next. This is, for some reason, it's coming as tabs. I don't want tabs, okay? So I'm going to get rid of the space and redo it as well, just to clean things up. I don't want that interfering, right? But here we need quantity, right? So this is quantity of 8. There's another tab here, so we're going to get rid of that and add a new space. This is going to be the value, like this. Which brings us to the end. We can go all the way, wrapping this part in curly brackets and a comma, okay? This is something that you might get as a JSON object, right? We didn't quote all these different values, these keys, but if you were getting this from an API, this might be the shape that you get, and you will get extra data in here that maybe you don't need, right? We'll see how that works in a second. So important to keep it in there just for a hot second so that we can do stuff. Now, down here, we're going to get rid of this because we are going to start with a map. Okay, so it's going to be pieces.map. That is going to be piece, and we are going to change it into the value. Okay, so that is going to be piece points for whatever the piece is, dot value. Okay. And then from there we reduce and we get our accumulator and our current. And this time around, it's going to be accumulator minus current. Keep hidden equals minus current. There it is. And starting at 39. Okay. 39 is a bit of a magic number. We'll come back to that in a second. But the way that you get there is 8 times 1, 2 times 5, 3 times 2. Again, 1 times 9. And then you sum those all up and it comes out to 39. This right here is not going to work because we need one little extra bit where if the king is not in our array, you'll notice it's always at the end here except for one of these. Okay, so king, 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 right? The king is in there somewhere. So if that array doesn't have the king, then it is checkmate. Okay, so we need to go and figure that part out. That is right here as an if statement. If pieces, which is an array, right, includes that king, then return checkmate in quotes. But not like this. We want pieces to not include the king, capital K. So if pieces does not include the king, then return checkmate. Otherwise, figure this part out, and that works, okay? This feels a little, it's a good solution. I feel like we can improve on it really, really quickly here. The first part being this 39, right? So if any of these values change or any of these quantities change, I don't know why the quantities would change, but values maybe, right? It depending on what the rules are for that chess tournament, the values might change, which means this hard-coded magic number will need to be altered, right? And that requires a developer. Whereas you could fetch the data, just get it, feed it in. This is hard-coded, and that is a bad time, okay? Even though it works here, it might not work always. So what we want to do is create a new function, and this is going to be called sum all pieces, okay? We're going to pass in an object and do some stuff. What are we going to do? Well, we're going to return capital O object values. Okay, so right here, finishing it for a hot second. There we go. Right here, we're just getting those values and we're going to do something with them. What are we going to do? Well, it's going to be another reduce, okay? Another reduce, if I can type, there it is, where we get that accumulator and the current, and we do stuff, okay? So right here, we are going to return, wow, can't type return either. That's so weird. The accumulator plus current dot quantity times current dot value, okay? Starting at 0, just like this, which means that now we're taking our accumulator, which is starting at 0, right? And we are adding the quantity times the value. In the case of the pawn, that's 8 of them times value of 1, which means that we're adding 8. We're adding 10 here, 6, 6, 9, and 0 for the king, okay? We can absolutely use this right down here, replacing this, and I should actually copy and paste this really fast just to keep things squared away. But sum all pieces like this, and we're passing in piece points, right? Not plural, piece points. Excellent. And that still works. But now we have a more flexible situation where so long as this value doesn't ever change, I don't know why we'd ever change the name of the king, right? But so long as that part doesn't change, we have a situation where this just works, okay? Now you'll notice that we passed in piece points. We didn't actually need to pass it in here. It's a nice to have, but we could have just done this and it will still work, right? But some other things in here are this map. That's the final place I want to finish today, because we could keep refining this until it is an elegant, clever one-line solution, maybe, right? But just getting rid of this second loop, we have 2 loops in here. So I want to clean that up really fast by taking this, cutting it out, getting rid of this whole line. So we're getting rid of that loop, and we are going to change this. So inside of here, we will return the accumulator minus all of this, and it should be current, okay? So again, instead of getting that value and then feeding that value in here, now we are passing in the accumulator, which is the number, the current, which is going to be a letter. We're using that current to get the value, and it still works, okay? But we've removed one of those loops, right? Because having these 2 loops slows things down, okay? It's not slowing it down by half, but it's pretty close, okay? It's slowing it down by probably about 75%. So anytime you can remove a loop, that is good news. So to bring it home, we've done all of this, okay? We started out by getting our data. And sometimes with our data, in theory, we'd be getting this from an API or some sort of a database where all these are set as constants, right? We aren't going to be, we could hard code them, but hopefully not, right? Which means that if they ever change in the future, we just get that information. And that's exactly how we've done it. So we started down here, building it out in a very manual fashion, hard coding some things. We took that out. We made a function so that we never have magic numbers, right? We're trying to avoid those magic numbers because, again, if any of these values change, now we need to go in and update this too, right? That's just extra work. I don't want to do extra work, so we're going to add a little bit of an extra piece in here. And then from there, we went ahead and we removed a loop to make it a little cleaner, a little easier to use, and a little faster, okay? That's it for today. That's, again, not every solution, just hopefully one really good solution. If you liked it, if you hated it, let me know in the comments. If you found a different solution you want to share, also let me know in the comments. Otherwise, today this has been Captured Chess Pieces, and I will see you tomorrow.